Okay, this is a little tutorial on how we calculate molar enthalpy change for a reaction. So we're going to look at the first question from the prep. So the first thing we need to do when calculating molar enthalpy change for a reaction is to calculate the value Q, which is the heat energy released when a reaction occurs. So to calculate Q, we need to use the equation Q equals mc delta T. So it's just a matter of plugging the right numbers into that equation. So we'll start with delta T, which is the change in temperature. And if we look at the question, we can see that the change in temperature is 12. C is the specific heat capacity. So it's a constant value, which is always 4.18. And finally, M will be the mass of the solution. So in this case, we've got 35 cm cubed of solution. And for solutions, 1 centimeter cubed is equal to 1 gram. So if we've got 35 cm cubed of solution, that will be equal to 35 grams. So if we put that all into a calculator, 35 times 4.18 times by 12, we get an answer of 1,755.6 joules. Now we need to calculate delta H, so molar enthalpy change. We use this equation delta H equal to Q, which we've just calculated, over moles. So in this reaction, delta H equal to Q, which is 1,755.6, over moles. And in this case, it'd be the moles of 0.14 grams of iron. So if we've got that, we do moles as mass over MR. So mass of the iron is 0.14 grams. The MR of iron is 56. So in moles, that is 0.0025. So we put that into our equation, and we come out with a value of this. Which we can convert to kilojoules per mole. At the moment, it's in joules per mole. So kilojoules per mole, we divide by 1,000. So 702.24 kilojoules per mole. And last thing to do is to notice that this is an exothermic reaction. We can see from the writing that we've got a temperature rise, so it's an exothermic reaction. So the last thing we need to do is to add a minus sign to our enthalpy change, because for exothermic reactions, enthalpy change is always negative.